Assalamualaikum warahmatullahi taala wabarakatuh. My name is Abdul Alim Muhammad bin Azmi, ID B0920102559. Today I will present lab measurement, subject, measurement and instrument, code BMMP 2503. Okay, for now I will explain on how to use height gauge. First, we need to clean the working platform and the measuring jaw of the height gauge. Second, loosen the locking screw of the height gauge. Third, move the slider to check if the LCD display and all the buttons work perfectly. Number 4 is we need to clean the measuring surface of the item that being measured with clean cloth. Number 5, use block gauge with the size of 20 mm, 50 mm and 100 mm. Number 6, make the measuring jaw and the platform surface gently touch the block gauge. Number 7, hold the rod against the surface plate and adjust the movable jaw to the nearest centimeter or inch. Number 8, get the reading from the large LCD screen directly. If that is happen when we use digital height gauge. Number 8, repeat step for the 3 times using different size of block gauge and record the data. Okay, for the micrometer, on how to use is, first, we need to choose block gauge with the size of 14 mm, 18 mm and 23 mm. Second, close the jaws of the micrometer and check for a zero error. Number 3, put the block gauge between anvil and spindle. Number 4, rotate the thimble until the block gauge is firmly held between the anvil and the spindle. Number 5, read the main scale and the rotating scale, then combine both of the value. Number 6, record the reading. And number 7, repeat the step from 1 to 6 for 3 times, like we usually do for to create the table data. Okay, now for the vertical optical comparator, how we need to use it is, first, place the block to be measured on the screen and adjust the height of the table to focus. Second, align the orientation of the side that need to measure on the project image with orientation of the screen reference line and adjust the value of XY stage to 0. Number 3, move the stage using the stage movement handle and align the other side of the projected image to be measured with the reference line. Number 4, read the value that display on the screen for X axis. Number 5, record the data in the table given. Number 6, repeat 1 to 5 steps for 3 times for X axis and Y axis, that is length and width. Okay, for the horizontal optical comparator, the step that we use is same as vertical optical comparator. First, we need to place the block to be measured on the screen and adjust the height of the table to focus. Second, align the orientation of the side that need to measure on the projected image with orientation of the screen reference line and adjust the value of XY stage to 0. Number 3, move the stage using the stage movement handle and align the other side of the projected image to be measured with the reference line. Number 4, read the value that display on the screen for Y-axis or for the X-axis. Number 5, record the data in the table given. Number 6, repeat the step 1 to 5 for 3 times for X-axis and Y-axis, which is length and width. Assalamualaikum warahmatullahi taala wabarakatuh. Now I will show you on how to measure using ruler and rubber. Okay, for the rubber, I will measure the thickness, the width and the length of the rubber. Okay, now for the length, we need to place the ruler on top of the rubber. We need to precise so that we can get the exact amount of the measurement. Okay, for the length is 3.5 centimeter. For the thickness is 1.1 centimeter, and for the width is 1.7 centimeter. That's all from me. Assalamualaikum warahmatullahi taala wabarakatuh. After 3 measurements that I have been conduct, this is the table data or data table that I get. As we can see, there is measurement error on 3 types of side, that is length, width and thickness. Measurement error is the difference between a measured quantity and its true value. It is included random error and systematic error. As we can see from the slide, there is formula to calculate percentage error. Okay, for the length, the percentage error is 76.65%. For width, percentage error for width is 8.35%, and percentage error for thickness is 31.13%. This error occurs because of the source of systematic error may be imperfect calibration of measurement instrument. It also can be because of change in the environment which can interfere the measurement process, and also can happen because of imperfect method of observation.